Hi everyone. So since our last video lesson, we have all learned that we're not going back to school this school year. And I know that means different things to different people. I want to say especially to the seniors how sorry I am that you don't get to have a fun end of the year like you thought. And you're missing out on a lot of the great things that come with the end of the year and being a senior. So I'm sorry, and I hope that you will be okay. And over the weekend, I posed a question to you on how you're doing, and I got such a wide variety of responses, and I'm so happy that I did that because it showed me a glimpse into your life. Now, some people are just bored because they're being cooped up in the house, and I'm kind of in the same boat, but there are some other people that are experiencing some real hardships, and I just want everybody to remember that no matter how bad it seems to you, there's always somebody else that's in a worse position than you are. So try to make the best of it, because that's what I'm doing too. So we're going to go on to the next lesson. So it is titled Indefinite Integrals. So we have studied definite integrals in the last couple of lessons. So it's going to be similar to that, but of course there is some differences. So I'm going to put this down and get the whiteboard so I can explain a few things. Okay, so when we studied definite integrals in the last couple of lessons, you saw the integral symbol, which is like an elongated S, and there was a function and dx. Now in the definite integrals, there was a number down here called the lower limit, and then there was a number up here called the upper limit. Well, in this case, they won't be there. These will be written so that there's no number on the top and bottom. So this is called an indefinite integral. So the important thing for you to know is that the indefinite integral represents an antiderivative. So it's just another notation, but it means the same thing. So in the previous lessons, we used a capital S for the antiderivative, but it really means the same thing as the indefinite integral of that function. So you're going to find that the answers for these questions that we do today will be a function, or I should say a family of functions, because remember how you put the plus c on the end, representing that any constant could be put in? That means that there are a wide variety of answers that you could have for each question with different values for c. Now with definite integrals, you got a number for an answer, like the last couple of lessons that we've done. But today it'll be just a function or a family of functions. So that's the key difference. Now you'll notice that there is a table of indefinite integrals below all this, and those should look familiar to you because they represent the antiderivative rules. So this is just another notation with the same rules. So get used to this notation. But notice that these are the same exact anti-differentiation rules that we've used in the past. All right, so let's get to it. Number one. So on number one, we have the indefinite integral, we call it, of 8x cubed minus 12x squared plus 2x minus 3. Okay, so we're going to apply the antiderivative rules, and this is just a polynomial, so this will be a pretty simple one. So the way the polynomials work again is you take the number 8, and you're going to divide that by whatever the exponent is plus 1. So 3 plus 1 would be 4. And then the exponent is also 4. So whatever's down here is also going to be here. And then you would just keep the subtraction sign. 12 would be the numerator. And then you look at this exponent and add 1. So that would be 3. So that would be also x cubed. The 3 here should match the 3 here. And then next we have the 2. And you're going to think, okay, that exponent is 1, so if I add 1, that would be 2. And then also the same exponent, 2. And then the last number, whenever you have a constant, you find its antiderivative by just putting it with x, like negative 3 times x. Okay, so that is the antiderivative, but we are going to simplify that. So 8 divided by 4 is, of course, 2, so 2x to the 4th. Minus 12 divided by 3 is 4, so 4x cubed. And then 2 divided by 2 would be 1, so x squared. And then that is still negative 3x. And then for your final answer, remember that you should put plus c to represent that any constant could be added to that to get a wide variety of antiderivatives. So the final answer for number 1 is this. So you might be thinking, well, how is this any different than what we did before? The answer is it's not. It's still the same thing. It's just that this is the notation for an antiderivative. Another word is an integral. So this is called the indefinite integral. So number 1, pretty easy. Okay, so for number 2, we have the indefinite integral. Now this one is a mixture. It's got a polynomial, and then it also has a trig function. But not to worry, we have rules for everything. Okay, so the polynomial will be the same as what we just did on the last example. So you write the 10. The denominator will be whatever this exponent is plus 1. So 4 plus 1 would be 5. X to the 5th. Remember, these two numbers should match. Now for the second part, this is not a polynomial, this is a trig function. So the negative 2 would stay the same. And then you're going to look at your chart, your table of antiderivatives or your table of indefinite integrals, and you'll see that the secant squared, this part, has a value of tangent of x. So just keep the negative 2 there, and then change this to tangent of x, and then simplify if it's possible. So 10 divided by 5, of course, is 2, so that would be 2x to the 5th. You can't do anything with this, so just keep it the same, minus 2 tangent of x, and then remember always to put plus c, meaning that you could add any constant to that and it would be part of the answer. Okay, so that would be it for number 2. So again, nothing different than we've done in the past. It's just that this is a new way to show it using an indefinite integral sign. So done with number 2. That one was also pretty easy. So number 3, we have indefinite integral. And we've got negative 3e to the x plus 5 over x dx. Okay, so this really means just find the antiderivative. So look on your chart or table of indefinite integrals, and you will see that e to the x has the same value when you do the integral or the antiderivative. So you wouldn't change the first term at all, not even the negative 3. Keep that the same. So you would have negative 3 e to the x. Now the second one is 5 over x. So if you look at your table, you will see that there is an option for 1 over x, and that is the natural log of x plus c. So the 5 just means that you would multiply 5 times the natural log, and it has absolute value symbols around x. So that's the only difference. If you see a number in the numerator, just use it as multiplication. So 5 times the natural log of x. And there's nothing else that you can do to simplify that answer. So you would just put the plus c on the end, meaning you could add any constant to it, and it would be the correct answer. So all of this would be the answer for number 3. All right. So those 3 were pretty simple, straightforward. The next 2 are going to be more complicated. I don't think I've covered either one of these in the past, so this will be something to pay extra attention to since we haven't done it before. Okay, so we've got a fraction, and it's quite lengthy. X cubed plus 7x squared plus 14x plus 8, and the whole thing is over x plus 1 dx. Okay, so you don't have a rule that's straightforward on your table of integrals, so you're going to need to go back to some skills from algebra and pre-calc that you haven't thought of in a while. So basically what we want to do is divide this polynomial by this one before we do the integral of it. So you learned in Algebra 2 for the first time, and then you saw it again in pre-calc, that you can do long division of polynomials. So you would have x plus 1 on the outside of a long division sign. On the inside, you would put your other polynomial, 1 in the numerator. And we're going to divide these two things. Okay, so long division, here we go. This is something you haven't had to do in a while. So what you do for long division is you take the first term here and the first term here, and you divide them. So x cubed divided by x would be x squared. So the x squared would go on the top of the long division bar, but you want to line it up with the other one that is a square. So you would put x squared right above 7x squared. Then you would multiply the x squared by both of the terms over here, multiplication. So x squared times x would be x cubed, and x squared times 1 would be x squared. Now when you do division, the next option would be to subtract, and the next step, I should say, would be to subtract. So you're going to subtract these numbers and these numbers. So the way to remember that you're going to subtract is to change the signs. So this is going to be a negative, and also this is going to be a negative. So you're going to switch it to the opposite sign of what it was. So once you change it to the opposite sign, you don't have to think about subtraction, you can just combine. So like x cubed and negative x cubed combined would cancel out. And this one would be 7x squared and negative x squared, so that's 6x squared. And then you will bring down the next term, so that will be 14x. And that would be considered one round of the long division. So now we are going to go through those same steps again. So you will look at the first term here and the first term here and divide them. So you would think, what's 6x squared divided by x? And that would be 6x, and it's positive. So you're going to put up here plus 6x, and it goes right above the 14x because they're the same thing, same variable. Okay, the next step would be to multiply 6x by both of these over here. So you're going to multiply 6x by both of these terms. So 6x times x is 6x squared, and 6x times 1 is 6x. Now when you get to this step, it's subtraction, but you will do that by switching the signs. So that 6 will be a negative, and that 6 will be a negative. Now the 6x squared and negative x squared, that cancels out when you combine it. And over here we've got a positive 14x and a negative 6x. So that would combine to make 8x. And then the last thing to do would be to bring down the 8. So that would be considered round 2 of the long division. So you're going to divide one more time, and you're going to take the first term here, x, and divide into the first term down here, 8x. So 8x divided by x is 8. So up here you would put 8. Then we would multiply 8 times both of these numbers. So 8 times x would be 8x, and 8 times 1 would be 8. Now we are subtracting, so I'm changing the signs. So this time you will find that both of them cancel out and you have no remainder. So what we have on the top, x squared plus 6x plus 8, is the same thing as what we started with. It's just in a simpler form. So it took a little bit of work to make it get to a form where we can do the antiderivative, or the integral, I should say. So this is not the answer, but we're going to need this to do our integral. So if you haven't caught up, please pause the video and catch up before you continue, because I'm going to need to erase what I have since I ran out of room. Okay, so I'm going to erase this. Now the answer that we just got, which was the part that was under the, over the long division sign, was x squared plus 6x plus 8. So it's like we have a new problem to work on. We have simplified what was up here to make it this. So now we will take the integral like we normally do. So this is a polynomial, so we'll follow the rules for polynomials. So the first coefficient is really a 1, so you will use 1 over. You'll add 1 to the exponent, so 2 plus 1 is 3, and then the x will also have a power of 3. So keep in mind whatever's here should match that. Okay, for the 6x, you keep the 6 the same. In the denominator, remember that this is really like x to the first power. So if you were to add 1 plus 1, you would get 2. And then the exponent is the same. This and this should match. And then if you see a constant number like 8, its integral is 8x. Then you will just go back through and simplify if you can. Like you can't simplify 1/3, so that one would stay the same, 1/3 x cubed. Here, 6 divided by 2 is 3, so that's 3x squared. And then just keep the 8x. And then remember to add the plus c so that any constant could be added at the end. So this here would be the final answer for number 4. So this part of it is the same. The part that was different is that sometimes you have to divide the denominator into the numerator using long division, which was a skill you learned in algebra and just likely forgot about because you haven't had to use it in a while. Okay, so finally done with number 4. One more and we'll have it. So catch up if you need to. Remember, you can always pause the videos, which is nice. You can't do that in real life. All right, so the last one, number 5, we have the integral, and it's 2x squared plus x squared square root x minus 1 over x squared dx. So this is similar to the one that we just finished, but you don't have to do long division to get your answer. You can just divide x squared into each one of these terms. So I'm going to rewrite this as individual terms. So it will be like 2x squared over x squared. The middle will be x squared square root of x over x squared. And then the last will be 1 over x squared. So these two things mean the same thing. Then we will go through and simplify. So in the first part, the squares will cancel out, leaving you with 2. In the second part, the squares cancel out, leaving you with square root of x. And on the third part, 1 over x squared can be written as a exponent that is negative. So that would be the same thing as x to the negative 2 power. And then dx. Okay, so we haven't taken the integral yet. We're going to do that next. But another thing I want to keep in mind is that this is a square root. And remember, square roots can be rewritten as exponents that are fractions. So let's change that now so we don't have to change it later. So instead of the square root of x, I can make that x to the half power. Okay, so now this is ready to do the integral. And this is just a polynomial, so we can use those rules. So for the number 2, if it's a constant, just put 2 times x. That will be its integral. Now the second one will be a little tricky. You have to put a 1 in the numerator, because that is a 1 over here. And you have to add 1 to the denominator. So you have to think of it, I'll do it over to the side, as 1/2 plus 1, which is a half plus 2 over 2, if you think of a common denominator. So really it's 3 halves. So 1/2 plus 1 is 3 halves. And x will also have a power of 3 halves. Okay, in the next one, you're going to use a 1 here as the coefficient, so that'll be the numerator. But then in the denominator, keep in mind that you have to, wait a second, I messed up on that one, sorry. Okay, so we're going to keep the negative sign there, negative x, and I don't have to use a fraction on this one. What you do is you add 1 to this yes, you have to add 1 to negative 2. I was losing my train of thought there. So if I add 1 to negative 2, that would be negative 1. And I feel like I just screwed that one up. Yes, I did. I'm sorry, y'all. I don't want to start this video over again, so please forgive Miss Craig. Having a moment here. Okay, so I do make it a fraction. So it's going to be a negative sign here, and I would put 1 over, because that's a 1. And in the denominator, it would be this number plus 1. So that's -1. And then x to the -1. So I was missing that part there. So sorry. Okay, so let's go back and clean this up. So we've got the 2x at the beginning. Now when you have 1 over 3/2, you would want to think of that as the reciprocal of 3/2. So that would be 2/3. And x would still have a power of 3/2. So it's 2/3 x to the 3/2. Now here, notice you've got a negative sign that came from the problem back here, and then the negative sign that came from adding 1 to this. So those two negatives make it positive. And then you have 1. And if ever you have a negative exponent, that means it goes to the denominator. So it would be the same thing as plus 1 over x. And then dx. Okay, so sorry for the confusion on that one. That is correct. So please pause it and catch up if you need to. And oops, there's no dx on that. That was our answer. Boy, I'm totally not doing so great on this problem. So sorry, y'all. And put plus c on it. Don't forget plus c. That's important too. All right, so finally done with number 5. Okay, so I hope y'all are doing okay. And please let me know if you need help at any time. I'll be happy to talk with you on the phone. We can text. We can do whatever works with you as far as getting help. So don't feel like you're in it on your own. You're not. I'm here. I'm working all day, so I definitely can answer questions. So let me know. Talk to you later. Bye.